Predict. Jūs pradedat.
Okay, dear colleagues, friends, fellow beekeepers, and everyone interested in the issue of pollinators. I myself, I am a beekeeper, where my father, grandfather, and great-grandfather. And now my children and grandchildren help me with my bees. Therefore, I fully understand and invaluability importance of pollinators to the environment, agriculture, and even family and cultural ties. Bees have always been especially respected and loved in Lithuania. Our most sacred bonds of friendship are strengthened by sharing bees. Pollinators bring at least 22 billion euros to Europe every year. Bees, bumblebees, and wild bees pollinate more than 80% of European crops and wild plants. Bees provide honey, pollen, wax, propolis, royal jelly, and other products, and are essential to agriculture and countryside. It is essential to protect bees and pollinators, and we cannot allow them to die senselessly due to a lack of communication between the beekeepers and farmers. We must protect them from new diseases and parasites. In the past decade, the EU has done a lot to protect bees and other pollinators, but there is still work to do. We have an EU Bee Health Laboratory created in 2011 to better understand the cause of bee mortality. EU strategies Farm to Fork and biodiversity strategy seeks to help the use of pesticides, reverse the trend of pollinator decline, implement the EU Pollinators Initiative. We in European Parliament are amending the Honey Directive in order to ensure more market transparency, better information for consumers, and less fraud. All these issues and many more will be discussed this week as we establish the EU Pollinator Week, that since 2012 aims to promote pollinator protection and knowledge across the European Union and to build bridges between the European citizens and institutions around the topic of pollinators and pollination. In the coming 3 days, we will have discussions on nature restoration law, new genomic techniques, sustainable use of pesticide, EU Pollinators Initiative, environmental risk, veterinary medicine, honey fraud, climate change, and many other issues, and how these relate to bees and other pollinators. I wish to thank all the MEPs, Commission representatives, BeeLife, beekeepers, experts, and everyone who will join us this week. It will be busy but interesting, and I wish and I hope that our discussion are fruitful, effective, and useful. Thank you. And now I would like to introduce Marta Hojsik, the Vice President of European Parliament from the Greens and very active in the issue of pollinators. Martin, the floor is yours.
Thank you, Juozas, and thank you for organizing the whole Pollinator Week and Bee Week. And just one small correction, I'm actually from the Renew Europe, not from the Greens, but sometimes it may look like that because of my activities, for example, on the field of the pollinator protection. Now, dear speakers and all participants of the Pollinator Week, I will have to wear two hats now. So first, please allow me to address you as a Vice President of the European Parliament. because as you know, our institution has been always in the first line of fight when it's going to the better protection of pollinators, both the wild ones as well as the honeybees. I would like to dare to say that despite the unfortunate plenary outcome of the sustainable use of pesticide regulation, we are still the very same institution being on the front line, demanding improved protection and action. Actually, we will very soon have an opportunity to prove this, namely during the approval of the nature restoration law agreement from the trilogue, which should happen no later than this Wednesday in the ENVI committee. I will, however, try to leave these technical, legislative, and procedural topics. As a Vice President of the European Parliament, I would like to remind you that just like the Pollinator Week, all other actions start with engaged citizens. Citizens like you who want something better for pollinators, for farmers, for future generations, for the planet. We should keep this at our hearts during the second edition of the EU Pollinator Week. Citizens, also in their roles of experts, citizen scientists, beekeepers, pollinator ambassadors, are those who are actually delivering the change. We politicians need to cherish that and really appreciate it. If not, we should pay dearly, dear citizens. So you will have it in your hands next year in the European elections, and think of the bees. And yes, I'm making this statement because of exactly elections. But now is also time to switch my hands, and let me share a few words as a former EU Pollinator Week chair. When I was organizing the first ever EU Pollinator Week in 2021, I was hoping to see the beginning of interinstitutional dialogues on the EU level, but also at home in member states, bringing concrete cooperation and obviously also celebration of these small, delicate species. The first Pollinator Week was challenging because of the COVID outbreak prevented us from meeting each other in person. However, it did not stop us from diving into buzzing discussions online. Far from that, I was also wishing that the Pollinator Week becomes a tradition, which will be carried by MEPs from different political groups, because the pollinators know politics. And also, this helps to show the political unity. Hence, I'm very happy that I could pass on the chairmanship to Juozas from the S&D group, and I hope that he will be able to pass it on the chairmanship to another MEP too, when the right time comes. But before he does that, I would like to wish him and all of other involved co-organizers good luck with all the sessions this week, and I hope the discussions will be fruitful and enjoyingly buzzing. Thank you.
Thank you, Martin, for your kind words and your activities here in the Parliament and strengthening this trend for the pollinator support to them. And now I'd like to give the floor to Dr. Johan Rockström, Professor, Director of Potsdam Institute for Climate Research. Professor, the floor is yours.
Thank you so much, Juozas Olekas and Martin Hojsik and everyone. Great to have this opportunity to start the important Pollinator Week with a science update on why it is so fundamental to preserve the functioning Earth system, and that pollinators is one of the functional diversity components that we all depend on. It's a global commons and will determine the outcome not only for human well-being for generations to come, but also fundamentally the state of the climate system and the functioning of the living biosphere. So I'll try to integrate thinking on pollinators and the role they play, but take it from an Earth system and climate perspective. Now, I think any lecture of this kind must start with the conclusion and the recognition that we are currently in a really turbulent state, probably for the world, the most turbulent social, ecological state since we left the last Second World War and entered the Cold War and exited that in the 1990s. We have a climate crisis, which we are deep into right now. We're deep into the biodiversity crisis, entering the sixth mass extinction of species, undermining life support systems across the Earth system. We have an exponential rise of zoonotic viral disease outbreaks, COVID-19 being one such attribution, just showing the risks we're taking when we overexploit unsustainably ecological habitats, because it's a zoonosis, a virus that spills over from wildlife via domestic animals to humans. And then, of course, the geopolitical instability with the wars in Europe, but also in Gaza. This is why we are discussing increasingly the risk of even moving towards a polycrisis point, where the undermining of the functionings of the living biosphere, where pollinators play a fundamental role, interact with social, economic, geopolitical, security, and health dimensions. All of this is a manifestation of the fact that we've entered a whole new geological epoch with the Anthropocene. Anthros for humans in Greek, we are now the dominating force of change on planet Earth. So this is the conclusion, I would argue, of the most important mind shift and paradigm shift for guiding our future on planet Earth, that we're now the dominating player. We're the dominating species. We are the ones that exceed geological forces of change on planet Earth. We exceed solar forcing, volcanic eruptions, earthquakes, just through the sheer impact of the globalized world economy. One such impact is the topic of today, that we're losing pollinators, species, ecological functions in an exponential rate. 68% of the populations of vertebrates have been lost since 1970. We are on verge of losing 1 million of 8 million registered species on land, according to the latest IPBES assessments. And we are following hockey sticks of extinctions of species across all animal family, and also insects and all forms of pollinators. Now, as you know, of course, the global assessment from the IPBES, the Intergovernmental Platform on Biodiversity and Ecosystem Services, have quantified the risk we're taking, that 72% of the nature for indigenous communities is being lost. We are basically at a 25% extinction risk of all species on planet Earth. And the drivers, looking a bit to the left on this graph, are also clear. It's land use change, it's exploitation for infrastructure and cities, and it's climate change. That adds up to over 60% of the causes behind losing pollinators and functions in the living biosphere. So climate change is a major driver, and here you have the hockey stick that we've unfortunately become very familiar with. We have 2023 moving towards clearly being the warmest year ever recorded on planet Earth. We've been touching 1.5 degrees Celsius, both in September and October. And here you have one of the explanations. We are causing an energy imbalance on planet Earth due to our emission of greenhouse gases, but we're also having a reinforcement because of the interactions between human-induced warming and the El Niño events we see with a higher frequency and more severe outcomes. And here you have the 3 super El Niño events just over the past 25 years, which interplay with our land use change impacting on pollinators, because it's driving rapid, actually unprecedented scale of changes in ecosystems across the world. We are seeing not only human communities passing the limit of adaptation, but also ecological communities passing the capacity of adaptation. And 2023 is a really worrying year. We just published this paper recently, led by Bill Ripple et al. From Ohio University, showing how over the past 50 years, our observations are moving off the charts in terms of ocean temperatures, in terms of heat waves. We have for the first year plus 50 degrees Celsius observations across all continents simultaneously. Now, this is something that is impacting ecologically, but having feedbacks socially across the world. Is this a state shift for the Earth system? We do not know. We cannot reproduce this in the models yet. We are clearly seeing the source of this, which is ocean dynamics, but we are not able to understand what is happening. And this is a warning we have. But the IPCC has been warning us. The 6th assessment of the IPCC clearly has the most clear scientific language so far in terms of linking the physics of climate change with the biology on planet Earth, which includes pollinators. Now, the high-level conclusions of the IPCC is that we're threatening human well-being already today, but we're also threatening the stability of the planet. And from the what I would argue for this discussion today, the most important finding in the lower part of this slide is that we now understand that maintaining the resilience of biodiversity and ecosystem services, where pollinators play the fundamental function, is a precondition for us to be able to have a safe, manageable climate future. In fact, the IPCC even concludes that we have to maintain up to 50% of nature on land intact to be able to have the carbon uptake and the carbon sink capacity, the moisture feedback dynamics, and the whole decomposure of organic matter functioning to be able to hold the 1.5 degrees Celsius line. So dear friends, it's not only about an energy transition to solve the climate crisis when we meet in Dubai next week, it's also about pollinators and the transition towards sustainable management of living nature. This means that we have come to a point when we now need to become stewards of the entire planet. We need to basically understand that now is the time to have the ability to reconnect our economies, our institutions, to pollinators and the living part of nature. And just to really raise the bar on what is at stake. We have so much paleoclimatic research today to understand that the state of the planet over the past 12,000 years, that's what you see here on the stable line, the Holocene, is extraordinarily stable. What you have here is the Osman et al. Paper from 2021, the meta summary of all paleoclimatic research we have available today, the last 20,000 years. On the y-axis is global mean surface temperature variation. The 0 point is 14 degrees Celsius, the pre-industrial average temperature on Earth. We leave the last ice age, 16,000 years ago. Pollinators have a rough time, to say the least, -6 degrees Celsius, 2 kilometers ice above the head where I'm sitting right now at Stockholm University. We leave the last ice age and we enter this extraordinarily stable 12,000-year period, the Holocene. We barely enter it, and we go from hunters and gatherers, a few million people living in caves, to domesticating animals and plants in the Neolithic Revolution, and off we go in the sedentary community to become citizens in cities and modern economies as we know it today. The conclusion is that the Holocene stability, which is when everything we recognize in nature settles in, all the ecosystems, all the big biomes, all the pollinators adapt themselves to stable agroecological conditions. We have rainy seasons coming and going in predictable ways. We have spring, summer, autumn, winter coming back every year in predictable ways. This is what settles in during the Holocene and gives us the nature as we know it today. And this is the world that has enabled us to thrive and to become a modern world with 8 billion, soon to be 9 billion co-citizens. The conclusion is as dire as it's simple from science. The Holocene is the only state of the planet we know for certain has the life support systems in the biosphere that can support humanity in the world as we know it. We've lived outside of the Holocene for sure. We've lived in caves as a few million hunters and gatherers, but there's no evidence that you can support the world as we know it outside of the Holocene. So the Holocene is the very reference point for pollinator volumes, for carbon cycles, for water cycles, for every planetary boundary we measure against the Holocene. Now, the challenge is that pollinators have settled in, have been often around for millions of years, have settled in as being the largest volume of living species on planet Earth, from insects to birds and then wasps and different small animals that carry seed across ecosystems. And their role is today well documented. In the IPBES, of course, you certainly have seen their pollinator report. Just to list the key conclusions, pollination plays a vital role for all forms of regulating ecosystem services. We would not have decomposure of carbon and organic carbon in soil. So if you want to have a productive farming system, you need functioning pollination and insects to operate in your ecosystems. 3/4 of global food crops rely to some extent on animal pollination. As was pointed out in the introduction by Juozas Olekas, the market value, both in the EU and globally, is touching upon the $1 trillion level. We have clear links between pollinators and healthy human diets and nutrition. We're talking big numbers of bees, flies, butterflies, bats, birds. There's a very wide diversity of response diversity for the function pollination. Crop yields really depend on this diversity. And we have, finally, multiple benefits to people. It's not only the direct service in terms of food, but it's also culture. It's also how we understand our own kind of home environments across the world. So it's about good quality of life to have a high degree of pollinators. And just to hammer home this message, because often I feel it's not really understood that pollinators are so fundamental. In ecology, we talk about functional diversity and response diversity. And pollination is one of the big line items in functional diversity, providing us with the function pollination. Response diversity is why we need a high degree of different pollinators providing this function, because they can then deal with different forms of stresses. So a long-range bumblebee can cope with one form of droughts, for example, compared to the short-range insects that may not be able to cope with a localized heat wave or drought. You want to have diversity in response to be able to deliver your function. This is often not understood, but let's just go to New York for a moment. If you would reduce the population in New York with 10% across the board, nothing would happen. But if you lose a function, like the police force, or let's say you lose the fire brigade, or even worse, that you lose the doctors, then the whole system collapses. So this is exactly why pollinators play in the ecosystems the same role as in social systems. You don't want to lose your police force. You don't want to lose your pollinators, because the whole system can collapse. This is what is at stake, and this is what has to be understood. The value I've already talked about, the major role of pollinators and biodiversity for the fundamental provision of economic development. We have so much evidence that pollinators are moving very rapidly in the wrong direction, not least because of pesticide overuse across the world. We even have increasing evidence that increasing frequency of hazard, climate extremes like floods, hurricanes, different heat waves, fires, are in themselves threatening pollinators across the world. This is kind of emerging evidence, but it's important to recognize that more and more climate research is also linking up not only to ecosystem impacts, but also on pollinators. So we're talking fundamentally about nature and pollinators providing stability, providing the fundaments of what I call Earth resilience, the capacity of the whole Earth system to cope with stresses and to compensate and enable the biological and physical systems on Earth to help us remain in a Holocene stable state. And let me give you some proof of that at the largest scale. This is the global carbon budget. The 2023 version of this will be presented next week in Dubai. It's a phenomenal piece of work, every year presenting the carbon cycle, which is not only the fundamental representation on life on Earth, because all net primary production in biomes, in the ocean and on land, fundamentally is translated into carbon. We are ourselves, as human beings, largely water and carbon. So here you have the carbon budget. On the y-axis, you have gigatons of carbon. Multiply that by 3.7 and you have it in carbon dioxide instead. Above the zero line, you have the classic hockey stick in gray, fossil fuel burning. We're burning in the order of 9 gigatons of carbon or 40 gigatons of carbon dioxide. The orange is the deforestation levels, all the land use change we're causing. Is it all that you see above the zero line here, which is causing the global warming so far, the 1.2 degrees Celsius of global mean surface temperature rise so far? The answer is no. It's not all that hockey stick that has remained in the atmosphere, because the dark green line is the uptake of carbon in the ocean, and the light green wedge is the uptake of carbon in living ecosystems on intact nature on land. So it's only the blue wedge in the bottom, which is the residual that remains in the atmosphere, causing the energy imbalance and the warming so far. This is, dear friends, the largest subsidy to the world economy by all categories. By all categories. It's 56% of our climate debt is hidden in intact nature and in the ocean. And on land, this is biology. This is photosynthesis. This is carbon dioxide fertilization. This is nature responding to stress and thereby absorbing more carbon dioxide. And it's pollinators doing the fundamental job. And what you see on this graph is something quite remarkable that even a kindergarten kid would say, isn't that quite remarkable? The more we punch the planet, the more she's helping us. And that is absolutely true. The number is roughly 50% every year over the past 150 years. The more we emit, the more a healthy planet with functioning ecosystems, with pollinators being in full response diverse mode, is continuing to absorb more carbon dioxide. The dilemma is we're starting to see cracks in this system. We see more and more scientific evidence like this, showing that big biomes are losing their carbon uptake capacity. In the middle here, you have the Xin et al. Paper that came out some 2 years ago, a 10-year synthesis showing that the Brazilian part of the Amazon has tipped over. It's no longer helping us. It's no longer a carbon sink, but it's a net carbon source. Dear friends, this is drama. This is Earth's richest biome on land with the highest representation of species and diversity, which is no longer helping us, which is tipping over from being a sink to now being a net source. We've been mapping what we call the irrecoverable carbon on planet Earth. You see them in these dark patches, the richest ecosystems on Earth that are holding the largest portion of carbon, in the order of 140 gigatons of carbon. Multiply that by almost 4, it is in the order of 400 or 500 billion tons of carbon dioxide. It's the same as the remaining carbon budget. It's actually exceeding the carbon budget to hold the 1.5 degrees Celsius line, held by nature, an intact, healthy nature, which depends on functioning, decomposers, insects, pollinators, to stay in that state. Now, you can combine this, the irrecoverable carbon, with estimates on biodiversity, and the darkest green parts here are those hotspots which has the largest biodiversity and the largest carbon sinks, which are, we would call them, irrecoverable, in the sense we cannot allow ourselves to lose them because we cannot restore them in time. I mean, it would take hundreds of years to restore them, well beyond the timeline we have to avoid unmanageable climate impacts. In fact, we published a paper quite recently showing that if it hadn't been for this nature, we would already have crashed through 1.5 degrees Celsius. So the carbon stocks and sinks from healthy nature are still helping us. It's just that we're seeing crack in their ability to continue providing that service. This is why we have developed the planetary boundary framework. It's to quantify a safe operating space for all the biogeochemical processes in the Earth system that regulates the state of the planet. Now you see the green space here. We've been able to quantify all the 9 boundaries. This is the 2023 update. You see 9 planetary boundary systems. I won't go through them in detail, but just to remind ourselves, it's not only climate. It's also what I call the biosphere boundaries. Biodiversity, defined here as biosphere integrity, both genetic diversity and functional integrity. And functional integrity is about pollinators. It's land system change, the configuration of biomes, it's the hydrological cycle, and it's overloading of nitrogen and phosphorus. These are fundamental parts of the living biosphere. And then it's the stability in the ocean, air pollutants through aerosol loading, and novel entities, loading of layer. 6 of 9 boundaries are outside of the safe operating space, according to our latest assessment, but most dramatically, all of the biosphere boundaries. So biodiversity, pollinators, land system, fresh water, and overloading of nutrients together form evidence that we're losing resilience. We're losing this capacity of the healthy planet to be able to buffer stress and keep the planet in a stable state. Now, on biodiversity, let me just say that scientifically, I'm really excited of the advancements we're making. And this is more for those of you who are interested in the quantitative details. What you see here is on the left-hand side, the so-called control variables we're using when we measure the planetary boundaries to quantify the safe boundaries for biodiversity. We've done it in the Planetary Boundary 3.0, the latest planetary boundary update. These are the two first columns here. And on the right, on the safe Earth system boundaries, is the Earth Commission synthesizing the state of knowledge on biodiversity, taking in broader inputs than only the planetary boundary science. Now, from this synthesis of science comes out 4 control variables, 4 ways of measuring the safe levels for biodiversity, and also then being able to map where we are today. The planetary boundary science has adopted genetic diversity, so the number of species extinct, functional integrity in terms of net primary production and the maximum allowed human appropriation of biomass. The Earth Commission used intact nature extent, so the percentage of area on planet Earth that needs to be maintained, secured, conserved as intact nature. And a second control variable for functional integrity on managed land, so in agriculture and forestry, what's the percentage of biodiversity corridors required for each square kilometer of managed land? And the number was set at least 20 to 25%. Now, the boundaries you see here in gray, the safe boundaries, and in color, you see the current values. And what you see is that both the planetary boundary indicators and the safe Earth system boundary indicators show that we are in the red, or for intact nature percentage in the yellow, which means we are in the uncertainty range in science, moving in a danger zone towards a point of high risk. This is a warning, but it's also very reassuring. Science with different lines of investigation, coming at biodiversity and pollination from very many different strands of inquiry, land at the same conclusion. We are in trouble. The lamp is blinking red. We need to turn around. It doesn't matter if you measure species or functional integrity or percentage of intact nature or biodiversity, pollinator corridors and managed nature, they all come to the same conclusion. And let me just show you the story on biomass in the world, because I think that's really important to understand. What you see here on the x-axis is the terrestrial net primary production in billion tons of carbon per year. So this is a good indicator of the functioning of the whole natural system. It's pollinators, it's soils, it's water, it's diverse plant systems. It's basically the whole measure of the Earth system's level of life. And here you have, taking that to the wrong level, here you have the Holocene, 56 gigatons of carbon, very stably. Not surprisingly, you have a stable climate, you have a stable hydrological cycle, so you have a stable nature during the Holocene. Here we have something really interesting. This is the response of a stressed system. The Earth system has added 16 billion tons of carbon per year in this stress response to our global warming. So this is what I showed you earlier, the carbon dioxide uptake in intact nature. But we are, on the other hand, as in the modern economy, taking out roughly 17 billion tons of carbon through deforestation, timber, all forms of biomass and bioenergy, and food systems. So in the end, we are currently right at this little circle point here, quite close to the Holocene point. So we're kind of cheating ourselves. We are allowing ourselves to overexploit ecosystems, undermining their resilience, undermining pollinators, but we don't really see the full impact because the stress response of the healthy remaining part of nature has been to actually camouflage this by adding more net primary production. And this is what we're not really understanding, and particularly not when it comes to discussing offsetting and compensating inability of phasing out fossil fuels with different forms of nature-based solutions, that we believe that we can just protect some forest and account for that against our coal or gas emissions. We cannot, because nature is responding through this stress increase, and that is way outside of the Holocene and needs to be protected very carefully. So this is our assessment. The green line here is the safe operating space. The yellow line is uncertainty range in science. The red is we enter high risk zone. The line you see here is the latest model. It's not even published yet on human appropriation of net primary production. And look how it goes. Already in the early 1900s, we really start raising our expropriation of biomass in living nature. So we need to start acting. And just in this little closing part, to say that I think we are finally starting to see a movement in the right direction. Certainly too slow, but the nature positive agenda is starting to mature and have more science alignment with policy. The COP15 decision on halting and reversing biodiversity by 2030 is, in my mind, a 1.5 degrees Celsius equivalent for nature, because it basically means halting the expansion of agriculture in the world. We need to now feed humanity on existing land. The pathway on climate is also very set. We need to reach net zero for land system change by 2030, net zero for energy use by 2050. And we need to succeed in all the carbon buckets that fundamentally are a prerequisite to be able to hold 1.5. It's not only the 250 gigatons of carbon budget for fossil fuel phase out, the one that everyone discusses. It's also that agriculture needs to go from source to sink, from +4 gigatons today to -5 gigatons in the second half of the century. Where do these numbers come from? It's from the IPCC modeling runs that can hold 1.5. So if you go into the CMIP 6 of the AR6 of the IPCC, the only scenario that can take us to 1.5 assume that number 2 will be delivered upon, that we can transition from source to sink in agriculture. Number 3 is also assumed in the models, that nature will continue to provide this phenomenal sink capacity, the stress response of -10 billion tons of carbon dioxide per year. Oceans the same, -11. Then we have, which I haven't even added here, assumptions on carbon dioxide removal with technologies. And we then finally assume no tipping points. It's just a reminder that number 2 and number 3 are all about pollinators. They play a fundamental part on climate delivery as well. There won't be a Paris range safely delivered without holding the nature carbon sinks intact. So the ideas of a nature positive trajectory is really important to turn around over this decade from losing ecological functions to start regenerating nature, to start not only protecting ecosystems, but also restoring and regenerating pollinator and ecological functions in healthy ecosystems as a human well-being pathway. We know that this won't be easy. David Obura, now chairing the IPBES, published this paper quite recently, just reminding us that even the most optimistic scenarios, showing this green line you see with the ecosystems to the furthest right here, which is a positive pathway, a resurfacing in a nature positive pathway, sometimes by 2070, 2080. The nature positive agenda, which is now on the table in Montreal, is much faster than that. It's assuming to come back into a net zero point by 2030, and that this is a much more rapid pace. It requires true actions. The nature positive initiatives around the world needs to be supported and needs to be scaled and accelerated. We need, which I know is your discussions here during the coming days, pollinator policies. I won't go through this list, of course, but just to emphasize number 7 here, supporting diversified farming systems. So moving on regulations for IPM, but also really moving towards recognizing that the diversified farming systems and cropping production systems, everything from crop rotations to mulch farming to different forms of conservation agriculture, are fundamental also to reestablish living ecosystems, living agrarian landscapes with thriving pollinators. Partha Dasgupta, who was given the task by the UK government in the run-up to COP26 in Glasgow, provided, I think, the most important economic analysis of the economics of biodiversity. And his conclusion that we now need strong sustainability measures, placing the economy inside the planetary boundaries, that the biosphere, the living biosphere, setting the targets for pollinators is an overarching target than the economy. The economy needs to respect these natural, finite, absolute functionings in the biosphere. Is there a pathway forward? Well, there are many efforts around the world. I just picked up this one that we're working with Conservation International on a nature law for carbon to work with nature to transition, as I mentioned earlier, from source inland, that is the Afolu sector, forestry and agriculture, from the 12 gigatons of carbon dioxide equivalent being emitted today. This includes methane and nitrous oxide. The carbon dioxide numbers I mentioned earlier was 4. 4 out of this is carbon dioxide. The remaining is nitrous oxide and methane. To be able to come to a net zero by 2030 and then start being a part of the solution in 2040, 2050, to really take up and permanently store carbon in nature. This is regenerating nature. This cannot be done without pollinators. It's not possible. So as a little final, let's say, mind map that could be worth, I think all of this fundamentally is beyond just pollinators. It really redefines sustainable development. It means that we now need to recognize that prosperity and equity, represented here through the Sustainable Development Goals, need to be delivered upon within absolute scientifically defined planetary boundaries. We're talking about Anthropocene. We're talking about the risk of destabilizing the whole system. We're talking about tipping points. We're talking about risks that can mean that the planet no longer can be providing the life support for future generations as we know them. So the transition into this kind of fundamental new thinking of thriving within a stable planet, I think, forms part of the pollinator story. With that, thank you very much, and back to you.
Thank you, Professor, for your very informative and very impressive presentation, and good to drive for the future, how we should act for the saving our planet. We have one question from our audience to you, Professor. Is it possible to share your slides for
Sure.
attendance for more?
Sure, we'll follow up on that. What we do is that my team will prepare a PDF version of it and send it over to you as the organizers, if that's okay.
Okay. Thank you very much. Dear colleagues, I would like to thank all of you, to Professor Martin for the being together in this opening part of our Pollinator Week, the event, and I hope that we will meet in the upcoming other discussion plenaries for our discussions today, and all 3 days, and it will be very busy but very informative and fruitful discussion about the future of pollinators in our countries and in this, all in the generally. Thank you very much, and I hope you see you next our meetings.
Thank you.
Thanks a lot. Bye there.